Okay, so I hope clear yung selectivity and sensitivity. Selectivity, this is the ability of the receiver to isolate the signal, the desired signal, and then rejecting all other similar signals. Sensitivity, this is the ability of our receiver to discern the weak signal, the weak desired signal, that when demodulated will still produce a unintelligible signal. Okay, now let's proceed to this receiver configuration. There are two types of receiver configuration that we can use. First is what we call the TRF. It's called tuned radio frequency receiver. This is the simplest radio receiver. It simply consists of a tuned circuit, a detector, and a load. Syempre may antenna siya. Now what you can see here is a TRF. So mapapansin nyo yung signal papasok sa antenna, and then it will be induced by the primary of this transformer to the secondary coil, which is in parallel with this tuner capacitor. Now this inductor and capacitor that are connected in parallel forms the tuned circuit. This will form the tuned circuit. Now, as you can see, C1 here is a variable capacitor, meaning we can vary the resonant frequency of this tuned circuit. We know that the resonant frequency of this is equal to 1 over 2 pi square root of the inductance times the capacitance. By varying the value of the capacitance, we are effectively varying the value of the resonant frequency. Now, sabi nga natin, if this is, kunyari, this is a wideband antenna, madaming signal na papasok dyan. Iba-iba. So, let's say 90, 100, 110, and all other signal. Okay. Now, the antenna does not have the capability of selecting a certain signal. Hindi niya alam yon. Antenna lang yan. Ang alam lang ni antenna ay tumanggap ng signal. Now, sino yung magse-select? So, we have our tuned frequency. Our tuned circuit. Itong LC tank circuit natin. Anong gagawin yan? By varying the value of capacitance, i-vary natin yung resonant frequency. So, halimbawa, ang hinahanap natin is channel, let's say this is channel 10, this is channel 11, and to, let's say channel 9. Gusto mong makinig sa channel 10, so va-vary mo yung capacitance. Bakit? Para itong tuned circuit na to will only resonate at this desired frequency, effectively filtering out all of the other frequencies. Okay, so kung ang resonant niya is 100 MHz lang yung makakapasok dito. Yan yung i-detect na nung ating diode detector. Okay. So, ito, the rest na to, diode detector, capacitor, the headphone is parang load lang din yan. This is the same dun sa ating diode envelope detector. So, tatlong stages ay 4, antenna, tuned circuit, provides selectivity, diode and capacitor C2 acts as the demodulator, and the headphones is actually our load. Yun nga lang, imbes na resistor nakalagay dyan, headphones, this is also a transducer that converts electrical energy into audio wave. Now, meron na tayo ngayong simplest radio receiver. Ganito sana kasimple, ganito sana ka-ideal, but we know that isa sa nagpapakomplicate ng ating circuit is the noise. So, the design of a PRF will usually not deliver the performance that is being expected for us today. One type of receiver that can overcome yung disadvantages of the noise is what we call the super heterodyne receiver. Super heterodyne receiver. Anong ginagawa dito? Sa super heterodyne receiver, there is what we call the heterodyne process. This is the process of converting a signal into another signal. Okay, by definition, these superhet receivers convert all incoming signals to a lower frequency. We call that the intermediate frequency. Tapos itong IF na to, itong intermediate frequency na to, ito yung pinaprocess ng buong circuit natin. Ito yung papasok sa mga amplifiers, sa mga filters, and ito yung i-demodulate natin. This provides the sensitivity and selectivity of our receiver. Now here, you can see here the simple block diagram of the super heterodyne receiver. Madali lang din ito, mukha lang siyang complicated. So, the first stage would be the antenna. And then after that would be the RF stage. And then after that will be the heterodyne na ito, the mixer local oscillator stage. And then we have the IF stage. And then demodulation. Yung AGC, automatic gain control, minsan meron, minsan wala. And then last is the audio amplifier. So dito sa mixer stage, dito nangyayari yung down conversion. Kino-convert natin siya from radio frequency into intermediate frequency. So from RF to IF. Yung IF, yan yung ipaprocess dito sa amplifiers and then sa filter. Yan yung iti-demodulate. So dito sa demodulator, paglabas niyan dyan, magiging na itong DC value noong intermediate frequency natin. Yan yung papasok sa audio amplifier natin, then this will be our audio frequency na. Yan na yung maririnig natin. Okay, so paano nangyayari yun? Isa-isahin natin. RF amplifier or the RF stage. This is also being called low noise amplifier. Ang ginagawa lang nito is i-amplify niya yung weak radio signal na nakukuha niya from antenna. So dahil amplifier yan, this will provide gain. Okay, and meron na itong unang selectivity. Bakit? Because itong RF amplifier na to, amplifiers are also designed to operate at a certain frequency. Okay, so meron na tong initial selectivity. Sometimes this stage is being referred to as pre-selectors. Okay, so sila yung pre-selector. So alin ba talaga yung nag-produce ng selectivity nandito sa mixer local oscillator stage? Okay, That is RF amplifier. Wala yang ibang gagawin. I-amplify niya lang yung weak signal na pumasok sa antena. Yun lang. Next is the mixer and local oscillator stage. So the output of the RF amplifier will be fed to the mixer. So ito na yon. The mixer has two inputs. Yung isang input niya ay manggagaling dito sa local oscillator or yung frequency synthesizer. Ang output ng mixer natin is actually apat. So the input signal, the local oscillator signal, and the sum and difference frequencies of this signal. So ano yun? So ito yung ating mixer. Di ba, unang input niya is RF, and then sa baba niya ang input ay yung local oscillator natin. Ano yung output niya? Apat. Una, RF. Pangalawa, local oscillator. Pangatlo, RF minus local oscillator, and RF plus local oscillator. Sum and difference. So apat na yun, no? Yung naging output. So dito papasok ngayon yung filter natin, yung susunod. So hindi naman po pwedeng tatanggapin mo to lahat. So alin dito yung desired frequency sa apat na to? Now here comes our IF stage. IF stage is a combination of IF amplifiers and IF filters. So ito yung IF stage natin. So, amplifier niya, anong gagawin nun? Wala, amplify lang yun. Wala masyadong gagawin yun. Filter, if i-filter out niya yung apat na input sa kanya, pipili siya ngayon doon. Alin ba doon sa RF, LO, RF minus LO, tsaka RF plus LO? Alin dito sa apat na to yung intermediate frequency? Yun lang yung makakadaan. Okay? So, dito sa buong superhet receiver, ang nagaano talaga ng selectivity dito is yung ating IF stage. Okay? So, that is our IF stage. Next is our demodulator. Ang gagawin lang nito pagka nakapasok na yung intermediate frequency signal natin, i-demodulate niya na. Katulad nung na-discuss natin sa AM demodulator, FM demodulator natin. So, same lang gagawin niya. Tapos yung output nito will usually be fed to an audio amplifier to drive the output speaker. That is our demodulator. Now there is an additional block here, AGC, automatic gain control. From the name itself, automatic gain control, this is a way to adjust yung gain ng ating IF amplifiers. So the output of the modulator is actually the original modulating signal. The recovered signal, which is usually AC, is rectified and filtered into a DC voltage. Di ba yun yung ginagawa ng crystal diode detector natin? This DC voltage is being fed back to the IF amplifier to control yung gain natin. So yan yung nagko-control ng gain ng dalawang amplifiers na to. Bakit? This will help to maintain a constant output voltage level. So, mapapansin nyo, pagka sa mga FM receiver nyo, yung, di ba pagkakanta, pagka yung medyo birit, tsaka yung medyo low notes, hindi ganun nagkakalayo yung volume. Kasi may AGC yung receiver natin. So, alam mong bumibirit na sa high notes, pero hindi pa rin nakakabingi pakinggan. Diba? So, AGC helps in that function. So, ito pa AGC helps the receiver to function over a wide range so that strong signals do not produce performance degrading distortion. Yan yung mahirap. Baka masyadong malaki yung signal, tapos ipinasok sa IF amplifier, hindi nagbago yung gain ng IF amplifier. Gain niya nung maliit yung signal, tapos gain niya nung malaki yung signal. Anong gagawin nun? Yung malaking signal lalong lalaki. Sobrang laki nun, baka ma-overdrive niya yung mga susunod na stages. So, magkakaroon ka ng distortion. Okay? So, that is our super heterodyne receiver. Now, balikan lang natin itong mixer stage. So, paano ba nangyari yung down conversion na yun? So, actually, we call it frequency conversion. This is the process of translating yung signal natin to a higher or lower frequency. Usually, ang ginagawa natin is we convert RF into a lower frequency. So, rare yung up conversion. Usually, what we do is down conversion. Frequency conversion is a form of AM carried out by a mixer circuit or converter. Itong ginagawa ng mixer natin, this is called heterodyning process. Like nung sinabi ko kanina, heterodyne process is actually the process of converting the input frequency into another frequency. So, yung heterodyne natin can be up or down conversion. So, ito yung mixer natin kanina. Sabi natin input niyan dalawa, yung input signal tsaka yung local oscillator frequency. The output of our mixer, apat. So it could be it will be the sum, the difference, and the original signal, FO and FS. So may asterisk siya dito. Sabi daw, it may or may not be in the output depending upon the type of mixer. But we will not discuss the different types of mixer. Tanggapin lang muna natin na ito yung mga output niya. Okay? Tapos itong output na to, ang dami, di ba? Ang daming signal. Papasok mo yan sa filter. Kasi hahanapin natin, alin ba dito sa apat na to yung intermediate frequency. Definitely, hindi itong FO, hindi itong FS. So, ang tanong, would it be the sum or the different frequencies? Okay, so ano ba yung IF? Depende yan sa mga system. Kung sa AM broadcasting, our intermediate frequency is 455 kHz. If we are in our FM broadcasting, the standard yan that is already set, so hindi ka pwede magbago dyan, is 10.7 MHz. As an example, we have here an FM radio receiver, and we have an FM signal of 107.1 MHz. Convert natin siya to an intermediate frequency of 10.7 MHz. Ang local oscillator natin is 96.4 MHz. Okay. So, meron tayo dito, input natin, 107.1. Local oscillator natin ay 96.4. Intermediate frequency hinahanap natin is 10.7. So, ang magiging output ng mixer is original frequency. Signal, 107.1. Local oscillator, 96.4. Sum and difference. Sum nila, 96.4 plus 107.1, that is 203.5. Difference nila is 107.1 minus 96.4 is 10.7. So, galing dito sa apat na values na to, alam natin na ito yung intermediate frequency. So, etong filter na to, dinesign natin to na yung kanyang resonant frequency will always be equal to IF. Kung FM ito, then it will be always equal to 10.7 MHz. So, kahit anong ipasok natin dito sa input niya, dahil yung kanyang resonant frequency ay 10.7 MHz, i-reject niya lahat ng frequency bukod sa IF. This is frequency conversion. Okay? Now, the primary objective of having an intermediate frequency is to obtain good selectivity. Bakit? Kung maalala nyo dun sa topic natin kanina about selectivity, the narrower the bandwidth, the better the Q, the better the selectivity. Para sa isang signal na nasa radio frequency range 107.1 kHz, masyadong mataas, diba? Ibig sabihin, ang bandwidth niyan will be also mas mataas. Tama? Kung mas mataas ang bandwidth niyan, ibig sabihin, imagine mo parang pinto yan eh. Kung mas malaki yung pinto, mas madaming makakapasok na noise. Diba? Now, if ina-narrow natin yung bandwidth niya by down conversion of the frequency from 107.1, ginawa natin 10.7, diba? 10 times smaller. Anong ibig sabihin nun? Yung pinto natin mas maliit. Ibig sabihin, mas maliit na noise yung makakapasok. Mas maganda yung selectivity natin. Tama? Now, there are various design benefits of using a low IF. Other benefits is that the circuit is much more stable with a higher gain. Bakit? At high frequency kasi nandito na natin kinoconsider yung stray inductance, stray capacitance. Kailangan na rin natin magkaroon ng shielding kasi may tinatawag tayong skin effect. Diba? Pag hindi tayo nag-shielding, ano mangyayari? Magkakaroon tayo ng undesired feedback. So, hindi na po pwedeng yung wire natin basta-basta ang wire tapos insulator na agad. Dapat may shield, may braid shield na yan. So, medyo mas complicated yung higher frequency. The problem naman of using low intermediate frequency is that prone naman ito sa image frequency. Ano yung image na to? So, papakita ko na lang. An image is actually a potential interfering signal. If this image frequency is allowed to enter the mixer, this will also produce the intermediate frequency. To give you an example, let's say that ito, example 1. Let's say that we have a desired frequency of 90 MHz and we have a local oscillator frequency of 100 MHz. The IF of this is 10 MHz. Tama? So, ibig sabihin, kung meron akong mixer, ito yung ating local oscillator, ito yung aking input frequency, Fs. Ito yung output ko. So, Fs, LO, Fs minus LO tsaka Fs plus LO. Ayan. Desired ko is 90. Local oscillator ko is 100. So, ano yung lalabas? Fs 90, 100. Fs minus LO, this is 10. Fs plus LO, 190. Tama? Now, what if may pumasok na isa? 110. So, Fs natin, 110, LO, 100. Difference, Fs minus LO, 10 megahertz. Sum, that would be 210. This is our desired. But this other signal also produces the same image or the same intermediate frequency. So, anong mangyari nito? Dahil pasok yan dun sa IF natin, 10 MHz, tutuloy-tuloy din yan dun sa IF stage natin. Now, this image frequency, ito, yung 110 MHz, will interfere sa system natin. Nagets? So, ayaw natin yan. Kailangan natin i-filter out yung image frequency na to. So, another, pwede naman kasi is nasa high side naman siya. Desired natin 110. Ito yung desired. Local oscillator natin 100. Tama? So, magbabaliktad lang ito. Ayan. So, yung 110, 100, IF niyan is 10, sum niyan is 210. Ito yung magiging image natin. Yung image frequency natin will also produce a difference frequency of 10. Tama? And a sum of 190. So, pwede siyang, yung image natin, pwedeng ito, nasa taas. Pwede din siyang nasa baba ng desired signal. To compute for that, mabilisan, ito. Pwede yung Fs plus 2IF or Fs minus 2IF. Kung mas mataas yung image frequency, itong plus ang gagamitin. So, anong image frequency? That would be Fs natin is 110. Sorry. Okay. Ayan. This will be 90 plus 2 times 10. 2 times 10, 20 plus 90. This will be 110. Yung ating image. Ito yun. Mas mataas yung image. Kung mas mababa naman, that would be ito. So, 110 minus 2 times 10 megahertz. This will give us 90 na image frequency. Okay? How do we solve the image frequency? Well, we need a good selectivity. So, kanina, our desired is 90 megahertz and yung nag-i-interfere is 110. Tama? So, this is the image frequency. Yung ating local oscillator is 100. So, para hindi na makapasok yung ating image frequency, then i-filter out natin ito. Ayan. So, sureball na yan, hindi na makakapasok yung 110 MHz. Okay? If the selectivity of the RF amplifier and the tune circuit is good enough, then the image will be rejected. So it will all boil down to our filter circuit. Now, another problem in our electronic communication system is our noise. So hindi naman natin to natatanggal, di ba? Noise is actually an unwanted signal. This is a mixture of many random frequencies at many amplitude na pumapasok sa ating transmission. This is not the same as the interference from other information signal. Pag sinabi mo kasing interference, halimbawa, nagsasalita ako tapos nagsasalita din kayo. So, yung sinasabi nyo would be an interference for me. Tama? Now, noise is actually unwanted signal, random signal. Halimbawa, nagsasalita ako and then merong kumidlat o kaya may bumusina, then that would be the noise to my system. Okay. Now, sa receiver, we know that noise is the most detrimental. Bakit? Kasi yung noise kasi maliit eh. Diba? Kung sa transmitter sumakay yung noise, walang problema. Bakit? Malaki pa naman yung signal natin doon. Pero kapag yung noise sumakay sa receiver side, kung saan weak na yung ating information signal, yun yung medyo mahirap na. Kasi halos magkapantay na si noise at si signal. Okay? So that is mas detrimental yung noise sa receiver compared sa transmitter. These noises, yung origin ng noise na to can either be external to the receiver. It can also be within the receiver itself. So, yung ating mga electronic components, gumagawa din yan ng noise. So, our noise can be external or internal. And in our receivers, both type of noises will actually affect yung sensitivity natin. Bakit? Because this will affect the signal to noise ratio. The more the noise, lalong tumataas yung ating noise level. Pag tumataas yung noise level natin, itong signal to noise natin ay bumababa. Okay, so that is noise. SNR, signal to noise ratio. This indicates the relative strength of the desired signal and the noise in our communication system. The idea here is that we want our S to be stronger compared to the noise. Para makakuha tayo ng higher signal to noise ratio. If our signal to noise ratio is low, therefore, hindi maganda yung reception natin. Unreliable yung communication system natin. Okay, so that is signal to noise ratio. Okay, so hindi mawawala yan sa system yung noise natin. What we do is we try to minimize the noise as much as possible. Okay, so that is our communication receiver. Thank you for watching this video and have a nice day.